Everything's done. Thanks, Sunil. Thanks, Steve.
Okay, last presentation before lunch. So South Africa is the world's 6th largest apple exporter and 2nd largest in the Southern Hemisphere. In 2021, South Africa exported over 600,000 metric tons of apples, worth more than 8 billion rand. However, this industry is under constant threat from plant parasitic nematodes, especially the root lesion nematode. Consumers currently shifted their consumer demand to a supply free of any chemical products, resulting in a biological control research emphasis in order to produce an organic apple. I'm Fourie, and I will be investigating the use of marigolds and brassicaceous cover crops as a tool for the management of root lesion nematodes in apple orchards. The root lesion nematode, Pratylenchus species, is the most abundant root lesion nematode in South African apple orchards. It causes reduced root systems, reduced water and nutrient uptake, stunted plant growth, and poor crop performance. And overall, of the 197 known plant parasitic genera, it is the 3rd most destructive. So how did I do this? Firstly, my objectives were to determine the efficacy of a cover crop as a pre-plant treatment for suppressing root lesion nematodes in infested soils, representing an orchard where apples were previously planted. Secondly, I evaluated the use of these cover crops to reduce root lesion nematodes in infested apple plants, representing an established apple orchard with root lesion nematode problems. And lastly, I evaluated the potential of marigolds to successfully establish, grow, and possibly reduce Pratylenchus species in a commercial apple orchard. So just quickly, my methods. I cultured the nematodes using the carrot disc method. I inoculated the soil and the apple plants using the carrot discs. I incubated these pots in a glass house, of which some I covered with transparent plastic bags to create a solarization effect. After the treatments, I planted a susceptible apple rootstock. I sampled and I evaluated the results under a microscope. So these are some of my results. Firstly, we had to determine if any of the host cover crops we planted were good hosts for Pratylenchus. In this case, none of the cover crops were a good host for Pratylenchus, although the free brassica species had a better host status than the fallow. The survival on these species was still below 20%. This data represents the number of Pratylenchus present in the apple plants as Pratylenchus per gram roots. This data serves as an indication of the Pratylenchus numbers in the soil where before the apple was planted. Only Tagetes patula, the French marigold, had a significant reduction when compared to the fallow treatment, which was the control. In the red graphs was the solarized soils. All the solarized treatments were different from the unsolarized treatments. So this is the reproduction factor. The reproduction factor was calculated using the initial Pratylenchus infection before the treatments and compared to the infection after the treatments were applied. So a reproduction factor of 1 would mean that the exact number of nematodes I inoculated the soil with was present after the treatments were applied. So thus, with no treatments applied in the case of the fallow, the Pratylenchus multiplied 5 times. Using the brassicaceous cover crops as biofumigation, the Brassica ginsea, Brassica carinata, and Sinapis alba significantly reduced Pratylenchus numbers in the soil and as well as in the apple roots. Tagetes patula and Tagetes erecta, the marigolds, significantly reduced Pratylenchus numbers in the soil, although Tagetes patula was not significantly different from the fallow treatment. Tagetes erecta did not significantly suppress root lesion nematodes inside the roots of the apple plants. Thank you.